Hey, this is Brent, and today we're going to go through the last video in the data modeling section of Developing Swift tutorials. And here we've got under Observation and Shareable Data Models, we have Complete a Game with Logic. So we'll go through that one today. And you do need to download the project files because this project has a lot of things that are already created for us. And so since we're focusing on working with data models, what we want is to download the project and use everything that they've given us. So go ahead and download that file. And once you have it downloaded, we'll go ahead and unzip it. So it's the Alphabetizer project. And then inside that folder, let's go ahead and open Xcode. It's going to prompt you, are you sure? And you say trust and open. Then it's going to load up. Let's take a look at what we have. So here you've got a project that is mostly complete. And it's divided up into folders with different content. And so here we've got a models folder. And we've got, if we take a look at that first one, you see a tile model. And notice it's got a few things here that we haven't seen before. It's got comments. So here, when you have the 2 forward slashes, then you have a comment. So that's a good way to leave a note for yourself or for other developers that are working on the project, what this item is doing, what this part of the code is doing. And then notice down here, we have a fix me, which is a special type of comment, and it shows up bold, and then you can also filter for these types of comments. And it's basically a way of reminding yourself to go back and fix this part of the code, because right now it's just returning one value. And so we're going to see a little more about this in the other code. Let's go on next to the vocabulary. Again, we have another comment, but notice this time the comment has 3 forward slashes. What this is doing, and then also we have a keyword called returns. So this is describing what this function does. It returns the count, which is unique random word from the words guaranteed unsorted. So this is just a comment. And when you use 3 forward slashes like that, this is called a documentation comment. And you can see that if you right click on this, let's right click on the function and click show quick help. Notice how it has the name and then it's got a return value. And so this documentation, so this text is from that comment. If I look down here and I, show quick help on this, it's not going to show any other comments because there's nothing assigned to it. It just shows you what it's related to, that sort of thing. If you take a look at, for example, if you right click on the keyword foundation and choose show quick help, notice you've got a lot of information there. And so this is a way of documenting your code. In the assets, we don't really have anything here, so we don't need to worry about that. Let's jump down to the views. So here we have our content view, and this is the entry point for the application, and it's composed of other views and some spacing. When this loads, we're going to actually switch to a different preview. Go ahead and come down here and let's just select iPad, and you can select iPad 13-inch. This game is designed for children, so it's easier for them to move a tile on the screen. And so this is going to be designed for the iPad. So the preview, we want to see this so we have a better layout. And again, when you're running this for the first time, the simulator has to load in the background, so it'll take a few seconds. Okay, so now we have it loaded, and you can go ahead and kind of fiddle with this as you move things around. You can click and drag the tiles. you can press the button, but nothing happens because we don't have the logic hooked up yet. And so you do see like this little animation on the button. And so that's what the rest of these views are. So let's go ahead and take a look at the message view. Here we're presenting different messages, and right now we have another comment where you've got, again, you have 2 forward slashes, and then you have this keyword to do. So to do is another way of reminding yourself of actions. And again, you can filter against show me all the to do comments, show me all the fix me comments, and then you can jump back and forth to find that. In fact, if I remember correctly, probably the simplest way is to come up to the search, and then you can say to do, and then you'll see each one of those in the list, and then you can also say fix me, and you can find those. So that's probably the simplest way to do that. Let's take a look at the score view. So here it just represents the score that shows up on the screen, and it gets incremented. And this is just the UI for that. We have the submit button. Again, we have another comment, a to-do comment, where we need to implement the action so that it does something when you press the submit button. It's got some animation and things. You can see that as you press it. Tile view here, again, a lot of this logic is already created for us, but for our purposes, here's a to-do, so we'll get this updated here in a little bit, but you do have an animation that happens there. And then finally, word canvas. This is where we have our drag and drop. And so again, we have layout and everything that's handled. This is all the code that handles that for us. We want to create another class file that will be the brains of the application. So come up here to the models folder, right click and choose new file from template. And then we want it to be a Swift file. Go ahead and choose next. And we're going to call it Alphabetizer. So here we have an Alphabetizer, and this is going to be a class. And so we'll say Alphabetizer. And the reason it's a class instead of a struct is that we want to have one instance of the Alphabetizer that we can reference throughout the entire application. And the class gives us that functionality versus a struct, which is something that can be, you can have multiple instances of a struct. You can have multiple instances of a class, but in order to use the class as a model that's referenced throughout the application, it needs to be a type of class. Again, we use a class instead of a struct because the class has the unique identifier, and that way we know that we're passing one instance of the Alphabetizer class to all of the views that need access to it. Let's add some properties. We're going to say private let tile count equal 3, and then we'll do a var tiles, which is an array of tile objects. And then we want a var score set to 0. So the tile count is obviously the number of tiles that we'll use on the screen at one time. The total tiles is the array of tile objects, and then the score is the running score that's used in the application. Next, we need another property. We'll say private var vocab, which is of type vocabulary. And because we're not initializing this, we need to use now a custom init function. So remember, when you're using the init, it's going to autocomplete. It's going to suggest all the properties, but we don't want that. What we want is specifically just setting the vocabulary property. And so we pass in a vocabulary, and then here we're actually going to set a default value. So we're going to say equals, and then dot, because the vocabulary, if you look over here, remember the vocabulary already has some predefined properties. So we've got land animals, ocean animals. So those are already predefined. Remember, the static keyword means that it's available immediately. It doesn't have to be instantiated, it doesn't have to be created before you use it. So here we can reference this. And so if we go back to the alphabetizer, what we're saying is we want of type ocean animals. Then inside we say self.vocab equals vocab. Now we want to create a submit function. If we use the 3 forward slashes, it creates, remember, it creates a documentation comment. So this will say checks if tiles are in alphabetical order. And then we say func submit. So again, this is a certain type of comment that shows up when you say right click on the function and say show quick help, and then it gives you that text here. For now, for the implementation of this, let's add a to-do comment for ourselves so that we'll come back to this later. So we're going to say to-do, and we're going to say implement submit. And for now, we're just going to have the score automatically update, increment it by 1. So every time we call the submit method, it's going to increment our score by 1. We're going to do a few things by default where as we go, we'll implement features one at a time. And so we'll have things that are temporarily used, but then we'll come back and fix them so that they actually do what we want them to do. Below the submit function, let's add another type of comment. And so 2 forward slashes, and then the keyword is mark. And so we use the colon, and then we say private implementation. Okay. So now what we're doing is we're indicating in our code, we're indicating everything below this line is what we will call the private implementation, meaning anyone who calls a method from the Alphabetizer class, they're only going to call submit. Everything else is going to be the functionality that's used by the submit method. So here we're going to create another one, and this is going to be a private function start new game. And so we'll say private func start new game. And then let's add a comment above that, and we'll use the 3 forward slashes to make a documentation comment, and it says updates tiles with a new set of unalphabetized words. Okay. You can see how these comments can help you keep track of things. One, you're adding documentation comments. You're also adding reminders. And then mark shows up when you're navigating within the application. If you look up here, notice we've got this little bar. This is called the jump bar, and it allows us to jump around to specific files within a folder and within our project. If you click at the top here on this far right item, you'll see a list of all the things in our code. And notice we have where it says private implementation, we have the little flag. And so here you're seeing the way that the comments are, you've got a to-do indicator, you've got the mark for the code. And so then as you add more, you're going to see this. And then this allows you to jump to different areas within the code. When you work on projects, they can get very long. The code in each file can get fairly complex. And you use these types of mark indicators to divide things up for yourself and to really leave notes for other developers, people who will work on the project with you, so that you're keeping things organized. So that's how you see that, and that's when you would use things like mark. Inside the start new game, the first thing we'll do is get a list of new words. So we're going to say let new words equals, and then it's going to be vocab, which is our reference to the vocabulary class, dot select random words, and then the number of words we want is the tile count, meaning how many tiles we're showing on the screen. And so in our case we have 3, so we're getting those words, and now we're going to loop through the new words array and then add those words to the tiles array by creating new tiles. So the way we do that is we say for word in new words, we will say tiles.append, and then we pass in, we create a new tile, so we say capital tile, and then it expects a word, and the word that we pass in is the one we just got from that array. So now we have taken the words from the vocabulary and we've created a tile for each word. So now that we have the beginnings of the brain of the application, we can start to reference the Alphabetizer class and pass it through within our code so that we can access the data and the methods that are here. In order for us to reference the Alphabetizer so that it will make changes to the SwiftUI views every time the value changes, we need to set a macro, and so we say at observable. So at observable is similar to what we did with the model, app model, where there you were using app model to use Swift data, and then SwiftUI automatically updates based on changes to the model. Well, here we're creating our model that is a class that lives in memory when the application is running, and we say at observable so that any changes to the properties here will then automatically update SwiftUI. For this to work throughout the entire application, we want to jump to the Alphabetizer app.swift file, which is the main starting point, which loads the content view. And so here we want to create a state variable. So we're going to say at state private var Alphabetizer equals Alphabetizer. So what we've done is we've created a state variable, and remember, a state variable means that everything that this content is now available to all of the child views of whatever view we're calling, and in this case it's the entire application. So that means that I can reference Alphabetizer in all of the views that show up in the content view, and because everything is a child view of the application, it will now be passed through to everybody, all the SwiftUI views that need the data. Next, we need to then pass that in as an environment variable. So we're going to say dot environment, and then we're going to pass in Alphabetizer. So what this does is we've initialized the Alphabetizer class once, and then we're passing that instance of the Alphabetizer class through the environment variable, which then can be available on all of our SwiftUI views. Let's go to the Word canvas and let's create an environment variable here at the top, to where we say at environment, and then we're referencing the Alphabetizer class so that it knows what properties to reference, and then we say private var Alphabetizer. Now what's going to happen is once you have this environment variable, the preview is now going to crash because it doesn't know what to do with it, because it doesn't have a reference to this Alphabetizer, because environment needs to be passed in. So remember, for the preview to work properly, you have to pass it in as an environment. And it's going to keep crashing until we fix it. So environment, and then we pass in Alphabetizer. So we're referencing the instance of Alphabetizer. So now it has stopped crashing. Now that we have a reference to Alphabetizer, we can, instead of using a state variable that creates some static tiles. Let's change this to private var tiles, and it's an array of tile objects. And then we're going to return the alphabetizer.tiles. So now we'll get a reference to those tiles that are generated in the application. Now, the problem is in our for each, we've all of a sudden, we're binding. Remember, when you have a state variable, you use the $ to bind the value so that when the content changes, then the Swift UI updates. But instead, we need to change this. Now, in order for this to work, we have to go to the tile model, and we need to make this also observable. So we say at observable. So now, and we also need to change this to a class, because remember, the class has to be a class because it has to have a unique ID, unique value for the tile. And so observable can only be a class, not a struct. So now we've got that. So if we go back to Word Canvas, and instead of the $, we can delete that. And instead of the $, we can delete that. So now that should load properly. Let's refresh. Okay, so this isn't showing up properly because I think I missed a step. Let's go back to the Alphabetizer, and I remembered, okay, so the problem is I didn't call start new game here in the init method. So when the Alphabetizer gets created, then it creates the list of tiles. So that's why the word canvas wasn't showing up. And so now this should refresh, and now we see that. So now we're pulling the list of tiles from our Alphabetizer class that has an array of tiles that gives us a custom, a random number of random words in our tiles. Let's go to the tile view, and rather than having a state variable, what we're doing is we're just going to have a reference to tile, which is now observable, so that we're centralizing, instead of using a state variable to automatically update the UI when the value changes, we're now referencing the model, where if the model changes, because we're using the keyword observable, which is a macro that has a bunch of stuff running in the background, then when in the tile view, when this changes, then it'll automatically update the UI, so we don't need to make it a state variable anymore. Here we've got this to-do that says on tap gesture, says we want to move it to the preview. So here we want to Command X to cut it, and then here we'll add it here. So now the reason for that is that we want to be able to use this animation, but we only need it in this preview. We don't actually, the animation is handled elsewhere. So again, this is just for the preview, and so we can remove that to do, so we took care of that. Let's go to the vocabulary, and here we need to declare a list of icons so that we can reference an icon for each item. And so if we come below the select random words method, then we say static let icons. So this is a computed property, and it's a dictionary. So a dictionary has two values. It has a key and a value, two parameters, a key and a value, and these are both of type string. And then we say equals, and then we use a bracket, and then, so in our case, we're going to say bear, and then we want a string for the bear. So we want, whoops, we don't need the colon, we want a comma. So let's take a look at this for a second. One, we need to use emojis in order for us to show the icon, so we're going to use an emoji. And there's a shortcut if you say Control, Command, and then space. It's going to pop up the keyboard lookup for emojis, and then you can just type bear and you can select that. So now it's inserted the bear emoji. This works on the Mac, and I think there's shortcuts on the Windows, but we're on a Mac, so we don't need to worry about that. Now, again, a dictionary is a key value pair. So the key is the word bear and the value is the emoji associated with that. We want to add emojis for all the animals. And the best way to do that is to copy and paste from the tutorial. So if you just go to the tutorial and copy, it's off screen, you can't see it. And then we're going to paste it. And so now what we've done is we have a keyword, an emoji for every animal that we have in our list, and that covers both the land animals and the ocean animals. Another way you can get to the special list is if you choose Edit and you say Emoji and Symbols, and so that'll do the pop-up as well. Now that we have our icons, we can go back to the tile model, and we're going to address this one where it says look up the icon. So right now it's returning a default icon, and what we want is to search. So we're going to say vocabulary.icons, and then we search for the word and we return the word, and if the word doesn't have an icon, then we're going to return a default value, and in this case we're going to say the shrug emoji. And so now the icon should return the vocabulary word. So again, remember in the vocabulary model, in that class, we have a static property called icons. When you're referencing a static property, you use the capital. You don't have an instance of the vocabulary class or struct. You have the actual, you use the name with a capital letter, and then you can reference any static property. So the icons is static, and we pass in the word, which is the word that is referenced by the title, and then if this doesn't have a corresponding value, then it's going to return a default. So that's what the double question mark is. It's basically saying if this is nil, then return this default shrug emoji. Now let's see this in action. Let's go to our tile view, and right now the tile view uses just in the preview just uses a word called word. Well, we don't have an emoji for that, so here let's just call it bear. And so now notice the preview updates, and hey, it got the bear. We can say crab, and then look, it updates the tile like we expected. If we go back to word canvas, then it's going to show up, and hey, all of a sudden, look, we've got real words and real icons that match those words. So here we've used the Alphabetizer class. We've passed that into the word canvas. We can do the same thing with the other views. So now let's go to score view, and let's change this up. So instead of having the score set by a state variable, we're going to use an environment. So we're going to say environment, and we're going to reference alphabetizer.self, and then it's going to be private var alphabetizer, and then the text is going to be alphabetizer.score. And then remember, we need to pass this into the preview in order for the preview to work. And so we say environment, and it's going to be the Alphabetizer instance. And so now everything is still the same. We can refresh. But now when the score value in Alphabetizer changes, then it's going to update this view. Let's do the same thing for the submit button. And here we need a reference to the environment. So we're going to say we need to create the alphabetizer from the environment, alphabetizer.self, private var alphabetizer. Boy, that word, alphabetizer. I'm going to have fun with that all day. Okay. Next, we need to pass in the environment. And so we say alphabetizer and we use the reference. And then in the to-do, we can now say alphabetizer.submit. So now we can call that method on that class. The next thing we need to do in order to address the message view where we want to reference a message. Alphabetizer right now we don't have any reference to message. So we don't have a message to pull from in order to display to the user. So to fix that, we need to add another model to our models folder. So right click, choose new file from template, make sure it's a Swift file, choose next, and it's going to be called message. And this is going to be an enum. And an enum is a set of values that are unique but related. And what it does is we're creating a message case for various states within the application. So we want a case that says instructions, and then a case that says try again, and finally a case that says you win. Because we're going to reference these in the alphabetizer for the message, it needs to be of a type of string. So we can actually set the type of enum, which is string. If we left it here, it would automatically convert the case to the string. So it would just be instructions, try again, and you win. But you can actually set a default string value that when you reference the enum in a string, it'll give you additional text. So now we can set this to actual instructions and other things that we want in order to present that message. For instructions, we're going to say equals place the tiles in alphabetical order. On try again, we're going to say equals almost. And then if you press the shortcut Control Command Spacebar, it actually brings up the emoji that's related to the text. So it's context sensitive, which makes it kind of nice. For you win, we're going to say you win, exclamation. And then you do Control Command Space, and now it actually gives you the options because there's multiple emojis associated with that, and we can select the trophy. Sweet. Now let's go to the alphabetizer, and here we can create a property for the message. So we can say var message, and it is of type message, and we can set a default to instructions. Now that we have the message associated with the alphabetizer, we can go to our message view and update this so that it brings in the information that we need. So here, again, we have an environment. So we say environment, and it's going to be alphabetizer.self, and it's going to be a private var alphabetizer. And then let's remove the to-do because that's what we're fixing right now. And actually we can delete this state variable because remember, we're passing in the environment, and then let's pass it in here, environment alphabetizer, and then here the message is going to be oh boy, I knew this was going to give me trouble. Alphabetizer dot message dot, we want the raw value. So in the message you have the case, it's an enum, and you have the case, which is this text here, but in order for it to display this default text, you would refer to it as the raw value. So now we have the raw value, and it's defaulting to the first item in the message, which is the instructions. If we want to verify that the other messages are working properly, we can change the preview so that we can reference the Alphabetizer just for the preview. So we say let Alphabetizer equal Alphabetizer, and then we could say Alphabetizer.message equals .uwin, and then we should return message view and then return the Alphabetizer that we just created. So now we're seeing the UN method. Again, this is just the preview. So what we're doing is we are referencing a different instance of the Alphabetizer class, but it's okay because we're only using it for the preview. And so now I can change this to almost. And then, oh wait, sorry. Try again is the thing, and then it returns the almost. So now we know that that works. So those are showing up as expected. Finally, we need to go to the content view and get the reference to our environment so that we're referencing the Alphabetizer. And here we'll go ahead and refresh. And now we can see everything that's hooked up in the application. So if I press the submit button, nothing happens yet, but notice that it loaded the tiles. If you click editor and we go to canvas and we say refresh canvas, it's going to bring up a new list of tiles. So we know that it's loading that, and we know the messaging and everything there. So we don't need an environment variable in the content view because the environment, we're passing the Alphabetizer through to any class that needs it. And since we're just passing it through, we don't need to update the state variable because we're not making changes within the content view specifically. So the content view doesn't care how Alphabetizer is being used. All it's doing is, hey, I'm passing this to my child views, which is everything that's here on the screen. We noticed that the submit button didn't do anything, and so we're going to start working on that now. If we go to the Alphabetizer and then we come into our submit, let's go ahead and remove this to do. And what we're going to do we're going to add a number of comments. And this is one way to keep track of kinds of the things that you need to do. So for example, first we need to check if the tiles are alphabetized. And then if they're alphabetized, we're going to say if alphabetized, increment the score, which is what this is doing. And then there's a number of other things. I'm going to copy and paste these because these are all in the tutorial, and it's a little, you don't need to see me typing it all out. But these are the steps that need to happen. So we increment the score, we update the message to win or lose, we flip over the correct tiles, and then we have a delay, and then if they won, then we're generating new tiles, we're flipping the tiles back, and then we're displaying the instructions. So these are all the steps. This is a good way of using comments to keep track of what you need to do within your application so that as you come back to this throughout the day, throughout the week, however long you're working on it, you're keeping track and reminding yourself, oh, this is what I need to do next. One thing we're going to do is we're going to create a variable just so that we can test some of the functionality. So we're going to say the comment says alternates true and false. And so we're saying private var is alphabetized equals false. And down here, we're going to have a to-do comment where we say compare alphabetical order to position. And so what we're doing is temporarily we're just toggling this is alphabetized. We're going to use this value in the code to generate what to show if they won or what to show if they lost. And temporarily we're just setting a variable that the first time you use it, it's going to say false, and then it's going to switch to true, and then back to false. And it's just a way of testing the logic in the application. So this is somewhat temporary. So here we're checking if alphabetized. We're going to say if is alphabetized, then we increment the score. Next, we would update the message. So we'd say message equals, and it's going to be, we're going to do a ternary operation where we pass in, we say, here's the true or false. So we're going to say, if it is alphabetized, then we're going to return .you win. Otherwise, we're going to return .try again. So here, what we've done is the message based on if it's alphabetized, then we're saying you win. Otherwise, we're saying try again. Next, when we flip over the correct tiles, we're going to say for tile in tiles. And we're going to temporarily just flip them over, whether we don't know if it's correct or not. So we're going to put a to-do that says to-do check if this tile is in the correct position. At the moment, we're not going to worry about that. We're just going to say let tile is alphabetized equal is alphabetized, and then we're going to say tile dot flipped equals tile is alphabetized. So at the moment, it's going to be returning true or false depending on what the current state of is alphabetized. And so we're going to see this in action here, but we'll fix this later. Then we want to implement a 2-second delay. And the reason for that is so that people can see the results. So when they've won, we would show that they won. And then after 2 seconds, it would start the game over automatically. So here, we're going to use what is called an asynchronous function. And it's specifically, we're going to say try await, and then it's going to be task.sleep for, and then .seconds, and then we pass in a value, so we're going to say 2 seconds. Now this is going to throw an error, and the reason it's throwing an error is because we're calling an asynchronous function that is not this class. It doesn't support concurrency. In order to support this, we can wrap this in a task block. And so what we're doing is, in fact, sorry, I'm going to put it up here. We're going to wrap all of this content. We're going to say task, and then the curly brace, and then wrap all of these next things in a task, because we only want these things to happen after the delay has happened. So remember, we used a task when we did an asynchronous call to load data when we're talking about Swift data. And so this runs outside of the Swift UI view, and then it comes back. And so we're waiting here. We want this to happen for 2 seconds, and then it will complete. And so we have to wrap it with a task block in order for this to satisfy. So now we don't have an error. One other thing we need to do is inside at the top of the task block, we need to say at main actor in. And the reason for that is we want all of this to happen on what is called the main actor, which is the thread or the operation of the way that Swift handles where certain functions are called. It needs to happen with the Swift UI, meaning all the Swift UI updates happen on the main actor. So when this is asynchronously happening, we're waiting, it needs to come back to and affect the UI, which is on the main actor. So that's why we say main actor in. Otherwise, we'd run into errors and it would crash if you tried to update the Swift UI and these changes happened on a different thread, which would crash. So because we're changing the UI views, we need to run everything on the main actor. Here under the if alphabetized, so then we say if is alphabetized, we want to tiles dot remove all, and then we want to start a new game. So that will clear the tiles and then start the new game. When we flip the tiles back, what we're saying is for each tile in tiles, we want to say tile.flipped equals false. So now it sets them back to showing the word. Now, one thing the tutorial mentions, it doesn't matter. It's okay if the tile is actually not flipped, if it was already set to false, because it's not going to make a change. The UI won't update if there's nothing to change. Then finally, for the instructions, we say message equals dot instructions. Okay, let's go back and see how this works. Let's go to the content view. And right now, the way we set up our logic, it's only going to, it doesn't matter. It's not actually checking the current position. What happens is when we press submit, it's going to say, oh, you won. And then it's going to reset everything. Now, notice when it reset everything, it didn't put them in the right spot. We'll fix that in a minute. But I want you to notice that when you press, it's going to say almost, because the logic is not actually set. And so we're alternating between true and false for is alphabetized. So just keep that in mind. So the app is not actually accurately evaluating these, because I can sit here and it says place in alphabetical order, and right now if I click OK, if I submit, whale is not in the right place, but it's going to say I won. So just remember that. So we haven't quite finished everything. So now we've got these tiles that need to be, everything is restarting, but the position's not right. So we'll fix that here in a minute. Now we need to update the UI so it behaves properly based on the logic. And one of the things that happens is we don't want the user to be able to press the submit button multiple times. Once you've pressed submit, it goes through, and if you've got the animation and it's waiting for that timer, we don't want them to click submit again. So to prevent that, what we'll do is go to the submit button, and here we're going to, on the at the end of the button closure, we're going to say dot disabled, and we say is enabled, and then what we need to do is create that property. So we're going to say var is enabled, which is a Boolean, and we're going to return true if the alphabetizer dot message equals dot instructions. Now we also need to let's see, missing, oh sorry, we're not making an assignment, we're actually doing a comparison. So remember, and I forgot, when you use two equals signs, you're doing a comparison. So this variable is returning true or false if this is equal to each other. And if you use one equals sign, you're not making a comparison, you're making an assignment. You're saying message is now equal to instructions, but we want to make a comparison. So remember the two equals signs. So now this button will be disabled. We use the exclamation point to say if it's not is enabled. So meaning if this is true, then we're not disabled. But if this is false, then we are disabled. Now that we have this variable, we can also change the UI, the visual appearance of the button. So if we come up here to the background, we can say dot opacity, and then we can use a check that says we can use that ternary operator, which means we say is enabled, and then if it's true, then we set the opacity to 1. Otherwise, we set the opacity to 0.5. So that means it's disabled. So now the color of the background will change. And then we can also animate the transition between the opacity by saying dot animation. And then it's just a default dot default. And then the value is based on is enabled. So now when is enabled changes, then it's going to animate. We can go and look at that. So when we click submit, notice the button is disabled, and then now it re-enabled after it got reset. So now that's working. We need to fix this so that the tiles get put back to their correct positions. Let's go to the Alphabetizer. And in the code that says if it's alphabetized, we're going to remove all the tiles. Instead of removing all the tiles, what we're going to do is we're going to keep the tiles, but we're going to update the word, reset the words and the tile positions. In order to reuse the tiles, right now when we call start new game, it creates a new list of 3 tiles. Instead, what we want to do is check if the tiles are empty and only create the tiles the first time. So we're going to say if tiles.isEmpty, then, and wrap this in the curly brace, if it's empty, then we create the tiles, we create the new tiles. Otherwise, so we're going to say else, we're going to, and add a comment, assign new words to existing tiles. And we'll fix that here in a second. So now we're going to reuse the tiles that we've already created. To do that, we're going to loop over the number of tiles, and we're going to make changes to both arrays. And so one way to do that is to say for index in, and we say 0 dot dot and then less than tile count. What this will do is for every item in the tile, we will then have a variable called index, and now we can say let tile equals tiles at index, and then let word equal new words at index, and then we say tile.word equals word. So what we've done is we've created a new tile, and we've selected a new word, and then updated that tile and word. Notice that we're iterating over 2 arrays. We have an array of tiles and we have an array of new words. They have the same number of items in each one. And so here we're manually looping through and we're referencing each one of those. We can actually do this faster, and there's a method called zip. And let's come back here, let's delete this, and we're going to say for, and then we'll say tile, comma, word, which are the variable names, in, and then we're going to zip the tiles and the new words. These are the 2 arrays. And then here. So now what we're doing is zip takes 2 arrays that are the same length, and now it automatically takes the first value out of one and the next value out of the other. So for example, in tiles, you're going to have the first tile, and then you're going to have new words, the first word, and then it goes to the next one and the next. And so as long as either these are the same length, it's going to zip them together like a zipper. So it's basically running this for loop twice as if you had done it like the other way. And so here we're referencing the variables tile and word, and now we're saying new word. Remember, the reason this works is because we're generating a set of random words every time start new game gets called. And so new words is always getting updated. So it's randomly, so every time. And that way, when we create the tile, we're referencing the same tiles we've already created, but we're changing the word. Let's go back and take a look at seeing this in action. So now, again, the logic is going to say you won, and then it's going to reset, and notice it flips it back and the position and everything is correct. Now, if we move the words, it says almost, and then we click, and then it's going to flip it, and then it's going to put them back. So what we've done is we've reused the tiles, but we haven't put them back to the right position yet. There's one other thing we need to do. We need to change, if we go to Word Canvas, when we want to use an on change event. So here on our Z stack, we have on appear, and it sets the initial tile position. In order to fix the position of the tiles, we want to reference another modifier called on change. And it's going to take when something changes. So we're going to say when the Alphabetizer dot message changes, then we're going to have an old value and a new value in. And so with that, we are able to now address the position. So we're checking when the message changes. Then we're going to see whether we're going to reset, whether we need to reset the position of the tiles. So we're going to use a switch statement. We're going to say switch, and you can actually switch on multiple values. So we're going to say old value, comma, new value. And the case, we're going to say case, if it's you win, if the old value is you win and the new value is instructions, then we're going to say with animation, we're going to animate this, press return to get the closure. We're going to say set initial tile positions. So what we're doing is we're comparing the old value to the new value. Oh, we also need a default. So let's say default. All right, so let's take a look at what we're doing here. When the message changes, we're saying what was the old value of the message and what is the new value. If the old value was you win and the new value is instructions, that means we need to reset the position. Set initial tile positions is a method that's already created. We don't have to worry about that. That code is already written. And so now it will call that. So let's go back and check. So if we move these positions, and then we click, and then it resets, notice it went back to the correct positions, and you saw that animation, right? Check this out. Right now it's going to fail because we're alternating. But if I click it, it says you win. And hey, check it out. It animated back to those positions. Pretty cool. Now we need to fix the actual logic so that we're checking if they're in the right order. So let's go back to the Alphabetizer, and under the submit where we say compare alphabetical order for the position, let's delete these two, and we're going to say let user sorted tiles equal tiles dot sorted. And then in the closure, we're going to do something, and we'll talk about it here in a second. So we're going to type $0 dot position dot x is less than $1 dot position dot x. So what this is doing is we're using a method called sorted, and we're customizing position. Wait, spell it right. Position. So in the closure, so the sorted function, we're making our own comparison. We've done this before where we're checking the value, and this is going to return the sorted if they're in the position. This is position.x has to do with the left and right position. So, if we go back to the content view, and if we're going position right now, this X position of this tile is to the left of this one, and this one is to the left of that one. And what we're doing is the position, the X is the position going left to right. So what we're doing is we're comparing this tile to this tile and saying, is this tile to the left of or to the right of that other tile? And when we do that, we haven't done anything with this yet, so that's why that error. But remember that these are shorthand when you use these. This is saying the first item, and this is saying the second item in the tiles array. Now let's use this information and to say let alphabetically sorted tiles equals tiles dot sorted. And here we're saying we're checking. So dot word dot, this is a long one, I know this is funny. It's funny to me, but just type it and then we'll talk about it. Lexicographically precedes, and then $1 dot word. What's happening, again, we're not quite done yet. We're still working through this. We've sorted. First, we have the user tiles. This is based on the position. So the tiles are listed based on how the user put them. And so that means if they put the first tile to the left of this one, then it goes there. Otherwise, it goes after. Here, we are sorting the tiles alphabetically. And the way we do that is, again, we're using a closure. We're using a custom sorting method. And we are saying if the first tile dot word is lexicographically preceded, in other words, if it's in order from the next one dot word, and this compares basically the alphabetical order of the word in the way that you would think of when you say, oh, this is alphabetically goes before this word. So what we've done is we have two sets of tiles sorted. We have the tiles are in the order that the user put, and we have the tiles that are in alphabetical order, and then we need to compare them. In order to compare them, we actually have to make a tile it needs an equatable protocol. So that means we need to define what makes a tile equal to another tile. And so we're going to use an extension. So down below, we're going to say extension, and we're going to say tile and set it to equatable, which is protocol. And then here, we're going to have our own custom function for equals, the two equals sign, which means these are equatable. So equals equals, and we've seen this before where it's the LHS, which is a tile, left-hand side, and then RHS, which is right-hand side, which is a tile, and then it's going to return a Boolean. Whoops. Come on, get my fingers over there. And then it's going to return a bool. And the way we compare is we're comparing they are equal if the left-hand dot ID is equal to the right-hand side dot ID. So that's the value we're going to use. So this is a custom comparison, meaning when you say this tile equals another tile, we're saying they are equal because the unique ID is the same. So that's how you know. So now we have the custom equatable. Let's go back to Alphabetizer. And here we need to remove this reference to the is alphabetized because we're not doing that anymore. And instead, we're going to set after these two sorted tiles, we're now saying let is alphabetized. Oh my goodness, alphabetized equals if user sorted tiles is equal to alphabetically sorted tiles, then is alphabetized will be true. So now let's go back and check if this is working. So remember, we take the tiles that are in order based on what the user did, and then we're alphabetizing the list of tiles, and then we're checking if they are alphabetized, and then we're updating everything accordingly. So now we go back, and here we check this, and right now when we click it, it's going to say almost, and if we click it again, it's still going to say almost because we haven't actually alphabetized it. But now if I put these in alphabetical order, then it says, hey, you win. And then it resets, and now we're back. And again, it's checking the position of each tile versus what the alphabetized order should be. And it makes the comparison, and then it works as expected. Let's go back to the Alphabetizer and let's clean up the last item. So here we're flipping over correct tiles. So here we're going to use a zip method over the user sorted and alphabetically sorted. And so then we're going to use that to check. So let's delete these two things. And we're going to say for tile, comma, correct tile in, and we're going to say zip, and we're going to zip the user sorted tiles and the alphabetically sorted tiles. And then we're going to say tile, let tile is alphabetized is equal to tile if it's the correct tile. What this is doing is we're flipping over a tile if it's in the right order, but they haven't won the game. So let me show you what I'm talking about. So if we go back, now what we've done is if, let's say we know that crab is the right order, but we have these two, so those are out of order. If I click, it says almost, it flipped over the correct tile. So that tells us, oh, that's in the right position. So now if I put that one there, and then if I put that one there, now they're all correct. So now it gives you that almost, it flips if the tile is in the correct position. Let's try this. Let's try it the opposite way. So if I have the last tile in the right position, see how it flips over. Pretty fun. You can see, if you go back to Alphabetizer, you can see the larger list of words by changing the vocabulary to dot land animals. And then you will have more animals to choose from. All right, very good. So that's the end of this tutorial. Pretty cool. Let's go and check all of our content and see. Let's do the end and check our knowledge. There was a lot in this video. Thank you for sticking with me. Hopefully this is helpful. I'll put in those chapter markers so you know where to look. So let's go down here and check our understanding. Which of the following is not a reason to use observable? You update Swift UI in response to changes in class properties, share a model object, uniquely identify data models. Okay, so we do share the model object through the environment. So uniquely identified data models is not a reason. Identifiable provides data models with a stable identity. Okay, how do you connect two collections of data? Well, there's zip. I'm thinking that's what it means. Yep, zip connects two collections to a single collection of pairs. Which of the following is an advantage of splitting code into multiple files? Smaller files are easier to understand. The code runs faster. I think it's this one. Right. Multiple types, each encapsulating a single purpose, are easier to understand than one big type doing everything. Awesome. Well, thank you for sticking with it. Again, be sure to like and subscribe, and I will see you in the next video.